Hi everyone. So in this video, I'm going to discuss the topic of polarization. Okay, and this entire discussion is based on from your NCERT. Okay, so this is going to be NCERT based discussion, and obviously this will be useful for your board examination. Okay. Now, as you can see here, we have a figure and representing the formation of wave in a string. Okay, now suppose a string, it is fixed at 2 points, okay, A and B, and then if you move the string, okay, in the suppose two persons are holding these strings at A and B, and they are moving the string like this. So there will be a formation of wave as shown here. Okay, so now obviously here the string, the particle of the string are vibrating perpendicular to direction of propagation. See, wave is propagating along x-axis. Okay, and this string is vibrating along y-axis. Okay, so this is the representation of a transverse wave basically. Okay, and this topic polarization is confined to the transverse wave. Means this is the phenomena which differentiates between transverse wave and longitudinal wave. Okay, so now the wave equation, since the particle are vibrating along y-axis, so this is the equation of the displacement of the particle, y, and now y is a function of x comma t, okay, and it is equal to a sine kx minus omega t, and this thing we have learned in class 11. Okay, now this is a transverse wave. That is the important thing about this. Why it is a transverse wave? Because particles of the medium are vibrating perpendicular to the direction of propagation. So this is the direction of propagation and particles are vibrating like this. Okay, so that is what is written here. It is a transverse wave. Okay, it is a transverse wave, and since the displacement is in y direction. Okay, now here we are going to use a new term also. It is often referred to as y polarized wave. Okay, y polarized wave. Okay, so here the particles are vibrating along y axis. Okay, so we call it as y polarized wave. Okay, and the string always remains confined to xy plane. Okay, see this, the string is, this is a string and it is oscillating in this direction. This is your x-axis, this is your y-axis. So basically this is your xy plane, this is your xy plane. Okay, and if this is z-axis, so this is the xz plane. Okay, so here the wave is confined to the xy plane. Okay, hence it is called plane polarized wave. It is called plane polarized wave. So basically, if the vibration of the wave is confined to a particular plane, then it is called plane polarized wave. Okay, so this is another new term which we have encountered. Okay, now there is another example that similarly, if we can have the vibration of the string in xz plane, generating z polarized wave whose displacement will be given by zx comma t, means now the vibrations are confined to xz plane. Okay, again the wave will be propagating along x-axis, but the particles will be vibrating like this. Okay, it will be vibrating in xz plane. Okay, so for that we will have this equation. Okay, so it should be, what is written here, it should be mentioned that linearly polarized waves are all transverse waves. Okay, why? See, just now we have seen the vibrations are perpendicular to the direction of propagation, so all polarized waves are transverse waves. And another thing is, only transverse wave can be polarized. That is another important thing. Okay, so if the plane of vibration of the string is changed, another important observation, if the plane of the vibration of the string is changed randomly in very short interval of time, then we have what is known as unpolarized wave. Why unpolarized wave? Because see, in polarized wave, vibrations are taking on a particular plane, on a single plane. Okay, but if we continuously change the plane of vibration such that vibrations are taking place in all planes randomly, then it is called as unpolarized wave. Okay, so unpolarized wave, this is another term. So unpolarized wave means vibrations are taking place in a single plane. Unpolarized wave means vibrations are taking place randomly in all planes. Okay, in all planes. Now let's proceed further. So now that was with regard to vibration in string. Okay, now because string we have transverse wave. Okay, so now this chapter is with regard to wave optics, so that is light. So here we are going to discuss the phenomena of polarization with respect to light. So light waves are transverse in nature. The electric field associated with the propagating light wave is always at right angle to the direction of propagation. Okay, so if this is the direction of the wave propagation, so electric field, they always vibrate perpendicular to the direction of the wave propagation. Okay, acha. Now what they have done, a Polaroid, they are taking a Polaroid and keeping that Polaroid in the path of the light. Okay, so what does a Polaroid has? A Polaroid consists of long chain molecules aligned in a particular direction. Okay, now if unpolarized light wave is incident on such a Polaroid, then the light wave will get linearly polarized. Okay, so when light wave is made to pass through a Polaroid, the light wave gets linearly polarized. Now why this happens? Okay, now suppose you have light wave, it is propagating in this direction. Okay, and you have electric field oscillating in this direction. Okay, and suppose transfers to this light wave is electromagnetic wave. So electric field and magnetic field are oscillating in mutually perpendicular direction. Okay, so now this blue color vibrations are in the plane of the paper, perpendicular to the plane of the paper, and green color vibration are in the plane of the paper. Okay, so now I can represent this also as like suppose this is the direction of the wave propagation. This is the direction of the wave propagation. Okay, and suppose this is electric field, and so perpendicular to the plane of the paper is represented by dots. Okay, now here we have a Polaroid. Okay, and for this Polaroid, suppose this is the pass axis. This is called pass axis. Means this is called pass axis. Pass axis means the vibrations which are in the axis, means the vibrations which are in this direction along the axis will be allowed to pass through the Polaroid, but the vibration which are perpendicular to the pass axis, they will not be allowed. Okay, so when the light emerges out on the other side, so only the vibrations which are in the pass axis, they will be allowed to pass, and all these dots will be missing. So that means now in this case the vibrations are taking place on this plane. Okay, on the plane of the paper, and the vibrations perpendicular to this plane are missing. Okay, these dots are missing. So this plane in which the vibrations are taking place, this is called plane of vibration. This is called plane of vibration. And the plane in which the vibrations are missing, that is called plane of polarization. That's called plane of polarization. So this is the Polaroid. So this is the Polaroid. So what it has done, see, this was the unpolarized light. And this is the polarized light. Okay, this light is the polarized light. So see, these are just terms, okay, to identify with regard to their properties. Like unpolarized light means the ordinary light where vibrations are taking place randomly in all directions. Okay, but here, after the unpolarized light passes through the this Polaroid, Polaroid is also called polarizer. Okay, Polaroid is also called polarizer because it is polarizing the light. Polarizing the light means it is restricting the vibrations to take place on a particular plane. Okay, we are forcing the light, we are making the light in such a way that the vibrations should take place on a particular plane. Okay, so this process is called polarization. Okay, so the definition of polarization will be polarization is restricting the vibrations of light onto a particular plane. Okay, so this process is called polarization. You are making the vibration, unpolarized light, vibrations are taking place in all planes. Okay, and in polarized light, vibrations are taking place on a single plane. Okay, so that is what is explained here. So what is this is shown with the help of a example. Actually, if light from ordinary source like sodium lamp, so this ordinary source means it is going to send unpolarized light, passes through a Polaroid P1, it is observed that its intensity is reduced by half. Okay, now we are going to understand this statement, why this intensity is reduced by half. When unpolarized light is passed through a polarizer, why the intensity is reduced by half, we will see that in a few moments. We will verify it mathematically. Okay, now rotating P1 has no effect on the transmitted beam and the transmitted intensity remains constant. Okay, so if P1 is rotated, if we have a ordinary light is passing here in this figure, we are having two polarities. Okay, but here, in this paragraph they are talking about a single Polaroid P1. So when the light is passed through P1, intensity is reduced by half. Now rotating P1 has no effect on the transmitted beam and transmitted intensity is constant. Okay, but if an identical piece of Polaroid P2 is placed before P1, okay, so now we have two Polaroids. Now P1 will make the intensity half. Unpolarized light is passed through P1, so intensity will be half. Now as expected, the light from the lamp is reduced in intensity on passing through P2 alone. But now P1 has a dramatic effect on light coming from P2. In one position, the intensity transmitted by P2 followed by P1 is nearly zero. So in one particular position of P1, the light which is passed through P2, intensity will be zero. Now, when turned by 90 degree from this position, P1 transmits nearly the full intensity emerging from P2. Okay, emerging from P2. Okay, so this is quite interesting in the sense, see what happens. This is ordinary light. This is ordinary light. It is passed through a Polaroid and vibrations are taking place in this axis. Okay, so if the pass axis, see here, if I keep another Polaroid, okay, and it is in this direction, pass axis is in this direction, that is suppose this is x-axis, this is y-axis, this is z-axis, so this is along z-axis. Okay, now these vibrations are in xy plane, so obviously if these vibrations are in xy plane, they will not be able to pass through this Polaroid and the intensity will be 0. Now if I rotate this Polaroid through 90 degree, in this direction through 90 degree, so now the pass axis will be parallel to these vibrations and these vibrations will be able to pass through and you will get the same intensity, means to the left of the Polaroid and to the right of the Polaroid you will get same intensity. Okay, so that is what is explained here. Okay, acha. Now we have based on this understanding, we have a law called Malus Law. Okay, now what is this law? Now suppose you have a Polaroid. Okay, this is the pass axis. This is the pass axis, and then you have another Polaroid. This is another Polaroid whose pass axis is this, and the angle between them is theta. Okay, angle between them is theta. So the light which is coming through this, its amplitude in this direction, it is a, this angle is theta. So component in this direction will be a cos theta. Will be a cos theta. So that means, see, only the light which is along the axis, pass axis of the Polaroid will be allowed to pass. So for this Polaroid, the amplitude in this direction, it is a cos theta. That means the light which is emerging out from this, it will have amplitude a cos theta. Okay, now we know that intensity, it is proportional to amplitude square. Okay, intensity is proportional to amplitude square. So here the intensity I naught will be equal to, suppose amplitude is a, so I naught is equal to k square. Okay, now intensity which is coming through the second Polaroid, it will be I proportional to a cos theta square. So that is I proportional to a square cos square theta. So that is I is equal to k a square cos square theta. What is k a square? K a square is I naught. So I can write this as I is equal to I naught cos square theta. Okay. So what is I naught? I naught is the intensity which is emerging out from the first Polaroid, and I is the intensity which is emerging out from the second Polaroid. Okay. So this is the relation between the incident intensity. See, on this Polaroid, on the second Polaroid, here the incident intensity is I naught, and here the emerging intensity is I, and angle between these two Polaroid is theta. So intensity is I is equal to I naught cos square theta, and this is known as Malus law. This is known as Malus law. Okay, acha. Now we have I is equal to I naught cos square theta. Okay. Now here we have two polaroids. So the first polaroid will call it as polarizer because it is polarizing the light, and the second polaroid will call it as analyzer because through this we are able to check whether the light is polarized or not. How we can check? Like if theta is equal to 0 degree or 180 degree. Okay, theta is equal to 0 degree or 180 degree. So in that case, I will be equal to I naught. Obviously, because if both polarizer and analyzer, their path axes are parallel, so the light intensity, if here it is I naught, that will, because vibrations are taking place in this plane. So this is the path axis, this is the path axis, both the path axes are parallel. So same light will emerge here, I naught. So therefore I is equal to I naught. Okay. Now if theta is equal to 90 degree, theta is equal to 90 degree, then second, but this analyzer will not be allowing the light to pass through. Intensity will be 0 because the vibrations are perpendicular to the path axis of this analyzer. So in that case, I will be equal to 0. Okay. Acha. One more thing. Just now we have seen here कि for ordinary light the intensity is halved. Okay. For unpolarized light the intensity is halved. Okay. So why? What is the reason? Here it is written. See, if the light from ordinary source passes through a polaroid, it is observed that intensity is reduced by half. So this thing we can explain on the basis of this Malus law. Okay. So how can we explain? See, so Malus law, we have I is equal to I naught cos square theta. Okay. Now unpolarized light means the vibrations are taking place in all planes. So this theta will keep changing. So since theta is changing, we need to take the average value of this theta. This is for unpolarized light. Okay. So cos square theta, average value of cos square theta. So what is that? That is 0 to twice pi cos square theta d theta divided by 0 to twice pi d theta. Okay. So this is 1 by 4 pi 0 to twice pi 1 plus cos 2 theta d theta. Okay. So if you integrate this cos 2 theta term, this reduces to 0. So we have 1 by 4 pi into 2 pi, that is equal to 1 by 2. So that means average value of cos square theta is half. This you might have also seen in alternating current chapter. So average value of this is half. So I is equal to I naught times half. So I is equal to I naught by 2. So intensity is reduced to half. This is for unpolarized light. This is for unpolarized light. Okay. Now let's proceed further. So now we have understood what is Malus law. Okay. Now next is polarization by scattering. Polarization by scattering. So light from clear blue portion of the sky shows a rise and fall of intensity when viewed through a polaroid which is rotated. When you rotate the polaroid, you will see that intensity is increasing and then decreasing. Okay. Now this is due to that the light is polarized. Okay. So here, so see, this is the sun, this is the light, unpolarized light, and then this is scattered by the particles in the atmosphere. Okay. So here, see, in the diagram we have as you can see here, there are dots and there are arrows. Dots means the vibrations are perpendicular to the plane of the paper, and arrows means the vibrations are in the plane of the paper. So this is unpolarized light. So light vibrations are taking place in multiple planes. Okay, and then it is scattered, and the scattered light, as you can see, only the dots are there. Okay, so scattered light polarized. Scattered light is polarized because this part, the vibrations which are represented by the arrows are missing here. Okay, so that means only vibrations are in only one plane, and that is polarization. Okay, that is polarization. So let us see what is given in the NCERT for us to understand. The dots stands for polarization perpendicular to the plane of the figure. The double arrows show polarization in the plane of the figure. So arrow is polarization in the plane of the figure, dot are polarization perpendicular to the plane of the figure. Now, under the influence of electric field of the incident wave, electrons in the molecules acquire components of motion in both these directions. Okay. Now, clearly charges accelerating parallel to the double arrows do not radiate energy towards observer, since their acceleration has no transverse component. Okay, so the vibrations which are in this direction, that will not be observed by the observer. Okay, so the radiation scattered by the molecule is therefore represented by dots, only the dots. Okay, so it is polarized perpendicular to the plane of the figure. This explains polarization of scattered light from the sky. Okay, so this is polarization, this figure for polarization by scattering. This figure is for polarization by reflection. That is the next topic. Okay, so polarization of scattering was also studied by C.V. Raman, and for this he was awarded Nobel Prize in Physics in 1930. Okay, acha. Now next is polarization by reflection. Polarization by reflection. So here this is the incident light which is unpolarized. So here vibrations are in the plane and perpendicular to the plane. Dot is perpendicular to the plane. Arrow is in the plane. So if the refracted ray and the reflected ray, they are mutually perpendicular. Okay. If this angle is 90 degree, then the reflected ray is polarized. Here you can see the reflected ray is polarized. Okay. Here the vibrations are represented by the dot. Only the dot. Refracted ray is the normal light, but the reflected ray is polarized. So this is polarization by reflection. Okay, and this condition that when reflected ray and refracted ray are mutually perpendicular, the reflected ray is polarized. This is known as Brewster's law. Brewster's law, and see here, as you can see, now this happens at a particular angle. So this angle is IB, that is Brewster's angle. Okay, it can also be represented as IP, polarizing angle. So obviously angle of incidence and angle of reflection will be same. So this angle will also be IB. Okay, this angle is R. Okay, so obviously this in here, if you see in this direction, you have IB 90 degree and R. So IB plus 90 degree plus R, it will be 180 degree. So that means IB plus R will be 90 degree, or R is equal to 90 degree minus IB. Okay, so if mu is the refractive index, mu is equal to sin IB, sin I by cos, sin I by sin R. Okay, that is a Snell's law. So sin R, now this is sin IB, sin R can be replaced by 90 minus IB. So that is mu is equal to sin IB by cos IB. So that is equal to tan IB. So mu is equal to tan IB. So if the angle of incidence is known, we can calculate the refractive index, provided reflected ray and refracted ray are visually perpendicular. And when reflected ray and refracted ray are mutually perpendicular, the reflected ray will be plane polarized. Okay, so when unpolarized light is incident on the boundary between two transparent media, the reflected light is polarized with perpendicular to the plane of incidence when refracted and reflected rays make right angle to each other. Okay, the angle of incidence is called Brewster's angle, IB. Okay, and then we have the relation mu is equal to tan IB. Okay, this is the deduction for that. Okay, that is also shown here in your NCERT. Okay, so this is polarization by reflection. Okay, so this was the entire discussion of polarization topic from your NCERT. Hope this video benefits you in your preparation. Okay, and please try to go through the things which are mentioned in NCERT, because I have explained each and everything from your textbook only. Okay.